All right. First of all, I apologize for the small font. I'll do my best to kind of point out the important stuff here. So this problem, first of all, this is a population growth problem, okay? And population growth sometimes can be expressed exponentially. And there's other concepts that talk about exponential growth or possibly decay. We're gonna focus specifically on two. One of them is population growth, and the other one is continually compounded interest in a bank account. Okay, so we're going to focus on those two. But both of those scenarios follow the same model of exponential growth and decay. Okay, so the model looks like so. You've seen this before, way earlier in the unit when we were talking about exponential functions. Okay, a few things to remember. I'm not going to label all of this again because you probably already have all of this down. Okay, this represents the initial amount. Anytime we use that subscripted O, that's called A naught. So A stands for the amount, right? When it's a subscript of a 0 or an O down here, that's the initial amount, right? E is not a variable. E is Euler's number, right? The natural base, 2.71828, blah, 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 blah. K, and this is where it gets a little wonky because K is a rate, okay? So this is the growth rate, okay, in this case, and it's gonna have to be turned into a decimal. So a lot of times it's given as a percentage, and you're gonna have to turn that into a decimal. You'll see that when we see the continually compounded interest questions. And then T obviously is a unit of time. So if you take some initial amount of something, multiply it by this power, okay, and I'm going to emphasize that point right now because it's going to come up again. This is 1 power, okay, where we have a product in the exponential level. Keep that in mind. This initial value that's in front, that's more like a coefficient, okay, not being raised to that exponent. Keep that in mind. And then if we calculate all of that, we get the amount after some period of time. So take some initial amount, multiply it times e to the power of a growth rate times a unit of time. All of that calculated together gets us the ending amount, if you want to think of it that way, or the amount after some period of growth. So in this formula, when the formula that we're looking at specific to this problem, 15.7 e to the 0.0416 t, right? These decimals get pretty weird. Models the population of a U.S. state A. So the population is A here in millions, emphasis on that, T years after 2000, okay? So T is the number, this T in this case is the number of years after the year 2000. So part A says, what was the population of the state in the year 2000? Well, we can use this model here, and let's reset. Okay, very specific to this problem, they're saying A equals 15.7 e to the 0.0416 t. Okay, so when they say what was the population of the state in the year 2000, t represents the number of years after the year 2000. Okay, so if that's in the year 2000, it's been 0 years after 2000, okay, at that point. So we'd actually be putting a 0 in this space, okay, and we can do that like so. Now we're multiplying 0 times this, right? So what happens? We get 15.7 times e. This whole product is 0, right? Now when we go to calculate this, you could type this into a calculator, okay? I wouldn't fault you for doing that, but you don't have to, because anything raised to the 0 power is 1. And I'm going to emphasize the same thing that I emphasized up here. This, right, is, even though it's touching the 15.7, even though they're pushed up, that's a power, okay, that has a value. So e to the 0 power is 1. So really what this becomes is 15.7 times 1, which is 15.7. Now that's 15.7 million as the population of the state. But again, just kind of jumping back to something that I mentioned earlier in the video, and that is, this is the initial amount before some period of growth, right? So when they say that this model predicts the population okay, T years after 2000, and then they want to know the population in the year 2000, so no time has passed, it would just be that initial amount right there. So something to consider. We didn't even have to do this entire calculation if we understand what the placement of all of these values is in this formula, okay? I got another thing I want to mention before we go on to the next video, but I don't want to make it too long.